whose purpose is to protect the body from invasion, right? It doesn't really have anything to do with circulating of waste fluid. But these two systems, the immune system and the lymphatic system, end up using a lot of the same organs. So there's going to be some overlap here, and I'm really hoping that it doesn't confuse you too much, all right? So many organs of the lymphatic system are used by the immune system, right, to clear the body of disease. So are we okay, the differences between the lymphatic system and the immune system? Okay. So basic concept of what the lymphatic system does, all right? You should be familiar with this kind of a picture here. This would be what kind of a vessel. Well, actually, let's start in the middle. What do you think these are? Those are capillaries. So what kind of a vessel would this be leading into capillaries?
Arterioles.
Yeah, okay, I'm hearing artery versus arteriole. Which one is correct?
Arterioles.
Right, okay. So arterioles bring oxygen and nutrient-filled blood into the capillaries where the cells can get at the oxygen and nutrients. You guys all know that, right? Okay. And so the cells use the oxygen and nutrients, and out of the capillary bed comes this little vessel, which would be a what? A venule. And the big difference between the blood in this vessel and the blood in that vessel is that this is loaded with waste, including carbon dioxide. Okay. So here's the big conceptual thing, right? It turns out that in order for waste and nutrients to actually get to the cells, the plasma, that's the liquid part of blood that contains oxygen and nutrients, actually leaves the capillaries. So as the blood flows through the capillaries, the plasma leaves the vessels and gets into the tissues, carrying all of the oxygen and nutrients with it. So fluid actually leaves. It's not just the oxygen and nutrient molecules that cross that boundary. It's actually the plasma. And towards the end of this capillary bed, that waste-filled fluid, right? It's called interstitial fluid, by the way. Most of it seeps back into this end of the capillary to be collected by the vein. But notice here, you see, I've got some red arrows here, and I've got some blue arrows there. Other than the color, does anybody notice a significant difference in the way that I've represented it? Pardon me? Which ones are going outwards? The red ones or the blue ones? Yeah, the red ones are going out, okay, and the blue ones are going in. Anything else you notice?
The blue.
Oh, the size and
The
the
size.
number. Okay, notice I've got large numbers of big fat red arrows here, taking oxygen and nutrients and plasma out of the capillaries, compared to not very many little skinny little blue arrows. So what I'm hoping, when you look at this, what this will immediately remind you of is that a lot more fluid leaks out of the capillaries than leaks back in, leaving this sort of backlog of waste-filled tissue fluid surrounding the cells of our body. Does that sound like a good thing to have? Have your cells drowning in waste-filled tissue fluid? I don't think so. So this is where the lymphatic system comes in, okay? The fluid actually ends up collecting in the tissues. It's got all the cellular waste. I'm just calling this being left behind. Oh, so sad, okay? And this fluid absolutely does need to be removed. So that is the job of the lymphatic system. Okay, this waste-filled interstitial fluid, the stuff that does not get back into the veins, is called lymph. And it uses the vessels of the lymphatic system to get back into the circulation. And this is how it does it, okay? And remember, it's a one-way flow. going from the tissues back to the heart. So that's why I'm calling it the semi-circulatory system, because it's one-way flow. All right. So what happens is there are tiny, itty-bitty little vessels that are all over the body. Okay, they're actually within the tissues. And as this excess fluid is created, it drains into these little tiny microscopic little channels that are called lymph capillaries. And the lymph capillaries eventually pass into larger vessels called lymph vessels. And it's the lymph vessels that you can see here in green, right, on this picture. And so these lymph vessels carry this waste-filled lymphatic fluid back to the heart. And there's actually a very specific way that this is going to happen, right? Very specific order in which they go back to the heart. But I'm going to save that for a second, because this next thing that I want to talk about is one place where the lymphatic system and the immune system interconnect, right? Because let's just imagine for a second that a particular area of the body, let's say it was infected or damaged or something like that, right? In that lymphatic fluid, not only you're going to have all the waste products from cellular metabolism, but you might have bacteria, you might have bacterial toxins, you might have dead chunks of cells, right, that leak into that lymphatic, into those lymphatic vessels. So, as the fluid flows back towards the heart, it passes through these little nodular structures known as lymph nodes. And the lymph nodes do two things to the fluid. First, they filter it of debris, and second, because lymph nodes are just packed with the cells known as lymphocytes. You guys know about lymphocytes, right? You just had that lab, right? So what can lymphocytes do to bacteria? Pardon me? They can kill them, absolutely. So as this tissue fluid flows through the lymph nodes, if the fluid is coming from an infected area, this is an ideal time to kill those bacteria before they get put back into the bloodstream, where they can therefore go everywhere. Does that make sense? Okay. So one point of intersection between the lymphatic system and the immune system are these lymph nodes. All right. Questions about this? All right. So a little bit about lymph nodes. They are kind of an interesting little structure. You're going to be seeing one of these under the microscope probably next week. All right. I like to call them the disinfection team, because as the fluid flows through, it passes through all of these little channels, gets exposed to different cells that can kill NPs. So the way that the fluid gets into the lymph node, see these little channels right here? Okay, these would be your lymph vessels. They enter into the lymph node this way. The fluid flows all through these channels, and eventually it leaves by these larger lymph vessels. And the closer and closer you get to the heart, the larger and larger these vessels become. Does that make sense? Okay? And hopefully, if everything's working right, the cleaner and cleaner the lymph is. Right? Until finally, it will then enter the good large veins that are right here in the neck. So, primarily, the two cells that we have here, I already mentioned lymphocytes, but there are also big cells in here known as macrophages. What does macrophage mean? What does macro mean? Large. Micro means small. Macro means large. And what does phage mean? Phagocytosis means to eat. So you were correct, right, that cooties get eaten in here, just not by lymphocytes. Okay, it's by a different kind of cell called a macrophage. So hopefully, as this lymph passes through here, any bacteria or viruses or chunks of dead cells are going to get removed. Now, can the lymph nodes do anything about the carbon dioxide in there? No. Can the lymph nodes do anything about the metabolic waste products that cells? No. Okay? So that's really what they're designed to do, is remove kind of big chunks of dirty, cruddy material, okay? Not the metabolic waste products. All right. So anatomy here, pretty simple. The outside of a lymph node is termed the capsule. This is dense, irregular connective tissue, just like you would expect to find. You've got a cortex here towards the outside of the lymph node that has these little, I don't know, sometimes I look at them and I think they kind of look a little bit like Hostess cupcakes, right? With kind of the cakey stuff and then the soft and gooey center, right? Well, these little structures right here are called germinal centers, and this is where the macrophages and lymphocytes are actually reproducing, they're actively reproducing. And then there is a medulla in the center through which that now filtered lymph is going to pass